All right. Hey, everyone. Today we're doing 10.2, which is all about arc length and inscribed angles. So arc length is something we should already be familiar with since we did things a little bit out of order this year with we did chapter 11, 11.1 first, and then we came back to do chapter 10. So hopefully arc length is just a refresher, and then inscribed angles is something that is new to us. So here we go. So first of all, what is an inscribed angle? Vocab word. It is an angle. Shocker. An angle inside a circle made by 3 points on the circle. And as we see in our example over here, angle ADC is an inscribed angle in this circle. So A, D, and C are all points on the circle. When you connect them in this way, it makes an inscribed angle. All right. And so we have inscribed angles and we also have arcs. And so when we're dealing with arcs in general, remember an arc is just a portion of the circumference of a circle. So this would be considered an arc. And the inscribed angle has a relationship with the arc's angle. And that is seen in the inscribed angle theorem. So if we're talking about this arc and this arc measure or has an angle, the central angle for the arc is typically shown like right here. So this angle, or the angle that makes this arc, has a relationship with this inscribed angle that also connects with the endpoints of that arc. So the inscribed angle theorem is that the arc measure is 2 times the inscribed angle measure. All right, so the central angle for that arc is 2 times the inscribed angle measure. So for example, if let's say this arc or this let's say this inscribed angle is 60 degrees. If that inscribed angle is 60 degrees, well then the central angle for this arc is going to be twice that, right? So 60 times 2 is 120. So this angle would be 120 degrees. And another way that you might see this written is next to the arc itself. You might also see 120 degrees written out there. So either of these places is fine if you're writing the degree measure of the arc. And it's going to be 2 times the inscribed angle measure. All right. So it also goes the other way. You could also use the inscribed angle measure and say that that's equal to the arc measure divided by 2. Or the arc's central angle measure divided by 2. So they have this relationship that one is twice the other. Wow, those colors look very similar to one another, blue and purple. Oops. Oh well. Anyways, here we go. So that's one thing that we need to make sure we know. The other thing that we need to know today is what an arc is. We need to talk about arc length, things like that. So with that, what is an arc? It is a piece of a circle or a piece of the circumference of a circle. And it's defined by an angle with a vertex at the center of the circle. Which is why a lot of times you'll hear it referred to as the central angle. There's also a lot of arc notation and stuff like that. So looking over here at this example, I know it's kind of tiny. But let's say that this angle, the central angle here was 45 degrees. I'll make this a little bigger. This is supposed to say point A and point B, and the center point is O. All right. So if you were going to name an arc, you do it in a very similar way to the way that you name segments and things like that. So if I wanted to talk about this arc right here, I would call it AB with a little arc over the top. Now, the only kind of question that remains from there is, what would I do if I wanted instead to talk about this version of the arc? The one that starts at A and ends at B, but goes around the other way? That one you would have to talk about by including some other point over here, like C. So if I were going to talk about this version of the arc, I would have to call it arc ACB. So arc AB, this is the version that you're going to deal with most often in this class. So anyways, arc AB, label it like this. Okay, so if we wanted to figure out what the length of that arc is, there's a few things that you need. You need radius or diameter, and you need the central angle. Okay. And so I know that we've talked about this before, and we talked about it in the context of a formula that we used. And so before we talk about it again in the context of a formula, I'm going to talk about it with more of a an approach that comes from the circumference. I'm talking about that. So we know that circumference is pi times diameter, or 2 pi times the radius, but usually we use this one. So step one of figuring out the arc length is finding the circumference. All right, so if we look at this particular picture, we know that the radius is 12, so then the diameter is going to be 24. So then when I do pi times diameter to get circumference, pi times diameter is going to be pi times 24, or 24 pi if we're writing things in exact form. And for now, we're going to leave it in exact form. So that's step one, find the circumference. Step two, you're going to take the central angle and divide by 360. Because 360 is the amount of degrees that's in a whole entire circle. So if I take my central angle of 45 and divide by 360, that represents the fraction of the circle that I'm looking for. So let's go ahead and do that. 45 divided by 360. All right, so now I'm going to bring those two parts together. We're going to multiply this fraction, that one, by the circumference. All right, so we're going to take and multiply that fraction by the circumference. So I'm going to grab both of these things, the circumference and the fraction. We're going to go 45 over 360 times 24 pi. And at this point, you're free to just type this into the calculator. So if you do that, and you can round to the nearest tenth at this point as well, you should get approximately 9.4. And so 9.4, whatever units you end up using. This one didn't include units, so it's okay to not include it here, or you can just put units if you want to. But 9.4 would be our arc length. Okay, so like I said, when we talked about this before, we used a formula. And the formula that we used was theta over 360 times pi times diameter, which looks pretty much like the same thing as this, right? It's a different, or a slightly different looking format in that we already figured out that the circumference was 24 pi. And we didn't use theta, we used just the angle itself as it was written over 360. But that's what theta represents, right? Theta is just this angle. When I take this angle and use it in the problem, I'm replacing theta with that angle. So if you like doing it the formula way better, great. If you like just taking the angle and plugging it in, taking the diameter and plugging it in, great. If you prefer this way of find the circumference and then multiply by the fraction of the circle that you want, it's the same exact thing. It's just a, the logical process, the way you think it out might be a little bit different. Okay. So today's assignment is an IXL section about inscribed angles. Tomorrow's assignment, though, is going to be in your packet already. It's going to be the worksheet on the next page. So let's go ahead and jump to the next page just to give us an idea of some of the notation in this worksheet is a little bit different than some of the notation you'll see on IXL. So I wanted to make sure that we go over that as well. So here we go. Okay. Find the measure of the arc or the angle indicated. So they want to find the measure of this angle in problem number 1. That angle corresponds to this arc. So notice out here how we have 228. That represents the degrees for this arc. We also have 62, which represents the degrees for this arc, RT. The nice thing is, we also know that there's 360 degrees in a circle. So that might be something helpful to write down, just in case we forget. 360 degrees in a circle, 180 degrees in half circle. Because on some of these, you'll also be working with a half circle. Okay. So if this is a whole circle represented by all 3 of these arcs, then all I have to do is go 360 and subtract away 228 and 62. All right. So we go ahead and do that, and we get 70. That means that this arc right here is represented by 70 degrees. Now that's the central angle measure. So since that's the central angle measure, if we remember our inscribed angle theorem, that tells me that the inscribed angle is going to be half of this. So the inscribed angle is going to be 35 degrees, because that's what you get when you do 70 divided by 2. You get 35. Oops, can't see that. There it is. All right. So 35 degrees would be my answer for number 1. All right. Similarly, we have a couple of other problems that we'll talk about here. This one involves a half circle, so you've got 110 degrees here. The other portion of the half circle is this one. You're looking for this missing angle here. Since a half circle is 180 degrees, I'll let you guys figure out what that one's going to be based on this. Let's jump down to one that's a little bit more difficult looking, maybe like number 5. Talk about number 5 together real quick. Okay, so number 5 looks a little bit more confusing just because there's more segments going on in the picture. So the angle that we're looking for is this one. So don't let the other stuff going on in the picture confuse you. It's very similar, actually, to problem number 2, because this is a diameter right here. So that means that this is a half circle. So if this portion is 104 degrees, this portion will be whatever makes up to 180, right? So if I do 180 minus 104, you get 76. So this arc must be 76 degrees. And then just as before, this angle is going to be half of the measure of the central angle for that arc. So then we can just go 76 divided by 2, which is 38. So that would be my answer for this one, 38 degrees. Okay. One final one that we'll go over together here is number 7. On number 7, we notice things are in a little bit of a reverse order here. This angle is 85 degrees. We are told that this arc right here is 86 degrees. And we want to figure out what is this arc right here. Okay, so 85 degrees is this angle that goes out to points K and F. That means it corresponds with this arc out here, KGF. In that case, remember we had this relationship up here where this arc measure, the central angle of the arc, is 2 times the measure of the inscribed angle. So we had to divide by 2 to get the inscribed angle. To go the other way, we have to multiply by 2. So we go 85 times 2, which is 170 degrees. So now we have 86, we have 170, and we have one that we're missing. So now all we have to do is go 360 minus 86 minus 170. And that's going to get us 104 degrees. So 104 degrees will be the answer of that arc's measure. All right. Hopefully this was helpful. Your homework for today is going to be in IXL. Tomorrow, though, your homework is going to be numbers 1 through 20 on this worksheet. So best of luck. I'll see you guys on Monday. Feel free to help each other out here. Have a good one.